Welcome to this explainer. Today, we are putting together your ultimate study guide for Earth skies. We're going to break down the atmospheric layers and those key instruments we use to actually track the weather. Let's just dive right in.
Here's our agenda. First, the protective blanket. Second, the 5 layers. Third, measuring the weather. And finally, a quick wrap-up.
All right, Section 1, the protective blanket.
So, our Earth is surrounded by this massive, invisible blanket of air called the atmosphere. And honestly, we depend entirely on this for survival. It gives us the very air we breathe, which, by the way, is a mix of gases like nitrogen, oxygen, and carbon dioxide. But it's way more than just breathing air. Think of it as a giant planetary thermostat and a protective shield all rolled into one. Without this blanket, we'd literally be baked alive by the sun during the day and then deep frozen at night. It is absolutely crucial. It's the ultimate climate control system that makes life on Earth even possible.
Moving right along to Section 2, the 5 layers.
Now, you might think the atmosphere is just this random, endless cloud of gas, but it's actually highly organized. It's divided into 5 distinct structural layers that extend from the ground all the way up into the dark vacuum of space. And each zone has a very specific, absolutely vital job to do. Think of this structure kind of like a giant ladder with 5 steps, climbing straight up from the surface into the cosmos. We start down here at the troposphere where we live, then step up to the stratosphere, hit the mesosphere, climb to the thermosphere, and finally reach the exosphere. Let's take this one step at a time. The contrast between these first 2 layers is just fascinating. The troposphere, the space where we actually live and breathe, is totally chaotic. It goes up to an average height of about 13 kilometers, and it hosts almost all our weather phenomena. I'm talking everything from dense fog to massive hailstorms. But if you step just above that into the stratosphere, which stretches up to 50 kilometers, the air suddenly becomes incredibly smooth and cloud-free. That's exactly why commercial airplanes cruise up there to avoid the turbulence. Plus, and this is a big one for your study guide, the stratosphere contains the ozone layer, which silently protects us from the sun's most harmful rays. Okay, continuing our climb, we hit the mesosphere, reaching up to 80 kilometers. Think of this layer as our planetary deflector shield, because this is literally where meteorites burn up the second they enter from space. Right beyond that is the thermosphere, spanning from 80 to 400 kilometers. Up here, temperatures start rising super rapidly. And interestingly enough, a section of this layer called the ionosphere acts like a gigantic atmospheric mirror. It bounces radio waves back down to Earth, which is actually what makes long-distance broadcasting possible. How cool is that? And finally, we reach the exosphere. This is the absolute uppermost layer. Out here, the air is just so incredibly thin that light gases like hydrogen and helium simply detach and drift gently away into the vast, dark expanse of space. All right, so having climbed all the way to the very edge of space, let's drop back down to Earth. Returning to our lowest layer, the troposphere, we've got to ask an important question. How do we actually track and make sense of the chaotic weather swirling all around us down here?
Let's get into Section 3, measuring the weather.
Well, before we can measure anything, we really need to clear up a super common misconception. Weather and climate, they are totally different things. Weather is the chaotic hour-to-hour or day-to-day change that dictates whether you need to grab an umbrella on your way out the door. It's the stuff that makes you feel gross when it's hot and humid or cheerful when it's pleasant and breezy. Climate, on the flip side, is the long-term historical average of those exact conditions over many years. So when we're talking about checking if it's going to rain this afternoon, we are strictly talking about the weather. And to track those hour-to-hour weather changes, meteorologists definitely don't just guess. They rely on 4 fundamental, really clever scientific instruments. Take a mental screenshot of this right now, because it's the ultimate cheat sheet for your exams. Let's match each instrument to its specific job. The thermometer, as you probably know, measures exactly how hot or cold the air is. The barometer tracks atmospheric pressure. That's the unseen force of air pressing down on us, and a change in pressure often tells us if we're getting clear skies or an incoming storm. Next, the rain gauge is a straightforward capture tool for measuring exact amounts of rainfall. And finally, the wind vane simply points out the direction the wind is blowing. And that brings us to Section 4, our rub-up. So, from the ozone layer up in the stratosphere, silently protecting us from the sun, all the way down to the chaotic troposphere, filling our rain gauges and spinning our wind vanes below, really take a moment to think about how this incredible, invisible blanket shapes your world every single day. I mean, it dictates the clothes you wear, it determines the food we can grow, and it literally provides the air in your lungs. And that officially wraps up our study guide. If this explainer helped you lock down these atmospheric concepts, please hit that like button, share it with your study group, drop a comment below with your favorite fact, and make sure to subscribe to our YouTube channel so you never miss an explainer. I'm going to leave you with this one thought. The next time you feel a sudden breeze or spot a shooting star, ask yourself, which invisible layer of our atmosphere is actually doing the heavy lifting right now? Keep learning, and we'll see you next time.